Hi everybody, this is Mr. Nolan, and we are going to finally finish our discussion of fluxes with some real-world examples. We're going to look at two. But what we want to be able to do with these real-world observations, we want to be able to basically look at a map, see how things change over time, and we want to be able to model fluxes and carbon pools from, in this case, Google Earth observations, or maybe you could look at a map and see how things are changing. So we know everything about fluxes now, right? You know about carbon moving in and out of certain carbon pools, organic and inorganic. We're just basically going to take some real-world examples, and I call this conceptualizing. We're going to really take something real, and we're going to apply our flux models that we understand to how do we illustrate this. So to do this, what we're going to do together is this says homework, but we'll do this together. We're going to model the carbon flux between a couple of carbon pools in some examples. Some examples of carbon pools might be forest or farmland or desert, or the atmosphere is an important one. And anytime that we're modeling really anything, we should probably use arrows. You should use arrows in this case to show flux. We want to show is the flux positive or negative? Is the pool organic or inorganic? Is there carbon dioxide involved? Is it organic carbon? Which pool is growing, which is shrinking? And what processes are causing or caused it? So what we'll do together is on this screen, I'm going to model this. So if you weren't here for class for this, or if you just, for your own benefit, if you want to go ahead and sketch this with me, go ahead and do that. Get a piece of paper. But we'll start off by going out and checking out Google Earth. Let's look at a few examples. So let's look at the model for Brazil. So there's certain areas in Brazil that we want to take a look at. So we'll take over here, we'll head over to Google Earth, and we're going to look at a real-world example, and we're going to try to get a sense for how can we model this. So this is a state in Brazil. If we zoom out, we can kind of see where we are. This big, huge chunk of South America is Brazil. We're just zooming into this state here. I'm not sure how to pronounce it, but it looks like Rondônia. And so here we are. And we can use a history feature in order to zoom back and forward in time. So let's go back to, let's say, 1984. Let's go back to about 30 or so years ago and look at the state at that time. So this is just kind of in a corner of Brazil. We can see there's a lot of green. We see there's these little, comb marks, these little streaks, these lines. It's really straight, sort of interesting. They almost look like streets or cities. And then if we zoom ahead to today, whoa! Look at that change. We go from, this green color to a really significant change, and really all over. That's happening over here in this state. I'm not sure how to pronounce that state's name, but we see this over here. We see it over in other places. There's lots of it going on here. It's also going on in Bolivia. Down here, we see some of the same situation going on. Sort of this almost sort of geometrical looking stuff. So a lot of people are tempted to look at this and say, oh, that's city, right? That's a city that has shown up in that space. Well, not so fast, because if we use our ruler, this is actually about it's 430 miles across. There's no city on Earth that is that big. So this is actually a really, really large area, and we can even figure out the area. So I can even use this neat little feature in Google Earth called Polygon to estimate the area of this change, and it looks like this says 74,000 square kilometers, a really fantastic change from 1984 to today. So if we zoom in, if we really take a close look at this, we see that it's actually not a city like it might look like, but if we zoom in, this is actually fields. This is fields. This is farmland or grazing where we can graze cattle. It's not city. It's not asphalt. It's not roads. This is actually farmland. So we can start to model what is going on in the state in Brazil. So let's think about this. I mean, this is the face of deforestation. This is what it looks like. 1984, it looked like that. Today, it looks like this. Pretty scary, right? This all used to be forests. So let's model this. Let's figure out what does this look like if we try to model what's going on in Brazil. Well, we really have two pools. We've got our organic pool. This is our forest. This is organic. And the forest is shrinking, right? It's definitely shrinking. And what they're doing in this rainforest area, they're not just cutting down the trees for the heck of it and for building farms. They're actually burning it. If you've ever heard of slash and burn, they're actually burning those trees. So if we jump over here, when we think about this, if you're burning it, what that means is that your carbon is leaving the forest and showing up in the atmosphere. Right? ATM, short for atmosphere. So we have our carbon, our CO2, because we're burning our forest. We have carbon dioxide leaving the forest and showing up in the atmosphere. Now, granted, there is still forest around, right? There's still forest, and it's conducting photosynthesis. And so that's pulling some carbon dioxide in. But over here, we're burning it, and we also have cellular respiration. So we're burning our forest. Burning or combustion. And we are losing our forest. Our forest is shrinking. So our forest is actually, so here what I've got my two pools. I've got my forest and I've got my atmosphere. These are really the pools that we're looking at. Our forest is burning, right? We have a flux. Our flux of carbon dioxide is leaving the forest. We do have some photosynthesis going on. We've got photosynthesis that's fluxing into the forest. But at this rate, with all this deforestation, the burning is happening a lot faster than photosynthesis. So this arrow really is thicker, right? This is a faster rate. This arrow is thicker. And so what that means is that we are producing CO2 a lot faster than we are absorbing it. So the forest has a big negative here. We have a big negative flux. And the atmosphere has a big positive flux. Granted, over down here, the forest still has a small positive flux, and the atmosphere still has a small negative flux. But overall, when we really look at this, if we were to graph our net flux, or draw it, that's what it looks like. Our carbon from the forest is showing up in the atmosphere. So our forest is shrinking, and our atmosphere is growing, right? Our atmosphere is actually getting bigger. So this is one example, one real-world example of trying to use flux to model, to show what's going on. The carbon from our forest is showing up in our atmosphere. So our net flux is from the forest to the atmosphere. For the forest, the net flux is negative. For the atmosphere, the net flux is positive. And this is really happening all over the world and all over South America. It's not just happening here. We can see it's happening really all over Brazil. This is all deforestation. There's some more, you can see swaths of it. Like I pointed out in Bolivia and some other areas, just millions of square miles of forests are being lost. So that's one example of something that we can model. Let's go ahead and look at a sort of a little bit more of an optimistic example. So let's go ahead and actually look at kind of an opposite example. So you might have heard of Mount St. Helens. Mount St. Helens was a volcano. Well, it is a volcano in the northwestern United States, and it erupted in 1980. And when it did, I'll show you some pictures here. So this is what it looks like today. You can see it kind of looks really similar to how it did in 1970. So this is 10 years before it erupted. So 1970 and today. So, I mean, the picture is different because it's better photography, but pretty much the same sort of thing. We see the same colors, we see the same amount, but let's go ahead and look at it right after it erupted, and we can actually zoom in a little bit. So this is it in the 70s, kind of bad resolution. This is it today, and so you can see there's some lakes and things like that. But let's jump back to just a few years after it erupted. Holy smokes! So what it looks like, all this was green, right? This was all trees. This was all green. And when Mount St. Helens erupted, all this ash, this huge area of ash covered all the trees and knocked them all down. Let's go ahead and take a quick measurement of this and figure out how many square miles or how many square kilometers is that. So if we use our polygon tool, we can sort of estimate that this whole area, maybe even that, I didn't include this up here, but a really large area was affected. About 250 square kilometers. That's a big area. When this volcano erupted, and we can see there was trees there was green, and now it's all this sort of brownish, grayish ash. So let's zoom forward to today and see how this has changed since then. So this is what it looks like today. So I'll zoom back and forth a few times so you can get a sense. This was it right after the eruption. This is it today. Right after, today. So that we can see the major differences is that trees have actually regrown. That in spite of this horrible disaster, Mount St. Helens erupted, killed a lot of people, the forest has actually regrown, even though it was sort of knocked down. So let's model this really quick, this sort of more hopeful example, and use this to think of how would we model this regrowth of forests. So let's jump over here. We're going to model the regrowth near Mount St. Helens. What we've got here is we have a situation where we have our forest, which is our organic, and we have the mountain, but I don't think, in Mount St. Helens, I don't think there was carbon coming in or out of that volcano, not very much. You can't burn ash, and you can't burn the rocks that the mountain is made out of. So I would not include Mount St. Helens in this model. We're really interested in the forest regrowing, which means I'm going to include the atmosphere again. So if we were to kind of buzz through this really quickly, over the course of time, that forest is growing, although there's also some cellular respiration going on. And the growth is driven by photosynthesis. So as that growth is occurring, the forest is expanding. It's getting bigger. Our forest actually is larger over time than it was earlier. And what that means is that because we have the same amount of carbon to work with, our atmosphere has got to be shrinking, at least in this area. So we actually end up with a smaller amount of atmospheric carbon dioxide than when we began. So we've got a big flux that for the forest is positive. So we've got a big positive here, a big negative here. We still have a small negative and a small positive there from cellular respiration. But in this example, our net flux is actually toward the forest because the forest is growing. And so we can say, all right, our forest is getting bigger and our atmosphere must be we must be pulling carbon dioxide out of the atmosphere. So as we regrow our forest, this represents the opposite of what we just saw in Brazil. Instead of chopping down trees and that's causing carbon dioxide to come out into the atmosphere, we are allowing trees to regrow, to grow back. And so that means that through photosynthesis, they're actually pulling carbon dioxide out of the atmosphere, and only a little bit of carbon dioxide is re-entering the atmosphere. Now remember, we're trying to model what this forest is doing after the eruption over time. We're not interested in trying to model the eruption. That's not very interesting. Well, it's interesting, but it really doesn't have that much to do with the carbon pools that we're interested in. So I hope that this was insightful and you feel a little bit better about being able to model carbon pools if you are trying to show through fluxes what those pools are doing. Are they growing? Are they shrinking? So these are two really good examples. Our Brazil example in the state where there's deforestation going on, and then in our Mount St. Helens example where we actually have regrowth of forest in which it's pulling carbon dioxide out of the atmosphere. So please check out my other videos if you feel like you need to, and I hope that this was helpful for you.